this is still 10.2, and we're still doing the funky LNs and the E's, only now we're going to introduce some logs, L-O-G. That means logarithmic. Logarithms are a way to redefine exponential information, as in numbers that get really big over time or numbers that get really small over time. Okay, so let's look at this. H says y equals 3 log, and then 5 is in the basement. So not 5 as an exponent, it's a subscript. It's in the bottom, in the basement. And then big old normal x. So this does not say 5 to the x. Everything that's big and normal is the 3, the log, the x, and then the 5 is a subscript. Okay, so let's look at how to find the slope of logs. Okay, I mean, not the slope. Well, yeah, the slope and the derivative of logs. Okay, so here's the log. The log rule says when you see a log, you're going to have log and then something in the subscript, call it little a, and then a bunch of stuff. To find the derivative, you take the derivative of that stuff all over the same stuff, and then LNA, and that's like LN, like capital L. Only in your homework, it looks like IN. So when you guys start sending me emails about, I don't know how to type this answer in the homework, I'll be able to tell that you didn't watch the videos or print off the documents, because you'll say, I keep typing IN. So anyway, on your homework, type LN. It looks like IN, but it should be an L. Okay, anyway, so let's go. This 3 just carries along in front, just like the past couple of problems. That's kind of nice. Okay, then it multiplies with a fraction. So a fraction of the derivative of the stuff. So the stuff is considered this letter X right there. That's considered the stuff. And there is a shortcut, but let's just do it the long way once in case you forget on a test. So on the top, we're supposed to take the derivative of the stuff. Well, we know that if you have like 5x, the derivative of 5x is just 5. The derivative of 2x is just 2. The derivative of x is just a pretend 1, because there's a 1 on that x. Okay, so for the top, I'm supposed to write derivative of the stuff. Well, we just figured out that the derivative of x is a 1. Okay, then we're supposed to divide by the same stuff that came from the parentheses, so x, and then multiply it with LNA, and A is that little bitty subscript, 5. Okay, now we're just going to clean it up, okay? This 3 on top, that's like saying a 1 underneath, and then we multiply left to right. Okay, so let's see. 3 times 1 on the top is a 3. 1 times all this stuff is just all this stuff. And I'm going to write it as X LN5. And again, on your homework, that looks like an I, but it's an L. You should probably type lowercase l, but when I write it, I use uppercase L so that you can tell the difference. So in your homework, you'll have to type lowercase l. Okay, let's look at part I that says y equals 5 ln x. Okay, well, let's see. For a number ln x, we kind of made like a little trick for that one. A number ln x just goes to that number over x. Okay, so this goes to 5 over x. Plus sign, because there's a plus before that 9. Now let's work on the logs. Okay, and if you noticed on this last example, that number in front of the log, eventually he just became the top of the fraction. That's going to be a trick we're going to use. So let's use that trick. And that one is right here. I think I wrote it right here. It says, if you have a number in front of your log, the number just gets smashed up on top. with the derivative of that stuff. So I think I'm gonna use this shortcut from now on so that we can avoid this whole 3/1, multiply left to right. Okay, anyway. So let's take the derivative of this 9 log 5x. It says you're supposed to put the number on top, like the number from before the letter L. So the number before the letter L is the 9. Okay, then we're going to multiply it with the derivative of whatever is after this log. Well, it's just an x. And on this previous example, we said that the derivative of an x is the same thing as 1x, and it goes to a 1. So times 1, woohoo, all over the same stuff, x, times L in A, where A is that little bitty subscript 5. Okay, so let's clean this up. We're going to have 5 over x plus 9 times 1. 9 over x times L in 5 is just x L in 5. And then you might be thinking, oh, okay, well, let's add this 5 and 9 because we did that on this example, E. But we were able to do that because the bottoms were exactly the same of the fractions. So we could add the tops. But on this sucker, the bottoms are not the same, so we cannot add the tops. So this is it. This is the derivative. And to show the derivative of a letter y, we put y prime. Bam. Okay, let's go to J. Oh, it has something different. It says 13 to the x. Well, that's something new. Okay. Well, let's look at our tricks for if it says, like, maybe a number with an x in the air. Oh, look, it's this exponential rule. We snuck it in here. It says when you see a number to the x, you write in one set of parentheses that exact same number to the x, and then you write ln of that number. Okay, so let's do that here. We're going to write down the exact same number to the x in parentheses, the exact same number to the x in parentheses. Then beside it, you put ln of that number, which is a 13. Okay. And then let's keep going. There's a plus sign because there's a plus sign before this e to the 2. And I don't know what to do with this e to the 2. Let's check our goodies. Well, this goodie says e to the x. That's not us. We have a 2 in the air. Okay. This goodie says e to the not just an x in the air. Well, I don't even have an x in the air. I just have a number. Okay. This rule says x to the e. I don't have that. Ah, here it is. It says if you have f of x equals e to the 2, then you use the constant rule and the derivative is 0. So the letter E is just a symbol that represents a number. Euler's number, that's like 2.7 or something. So E to the number is kind of like saying pi to a number. You know how pi is just 3.14? Well, if you square that, it's still a number. Same thing for us. The letter E is just a number. It represents 2.71. So this is really just saying 2.71 squared. And that's just going to be another number. Well, what's the derivative of a number? It goes to 0. That's why you have to use the constant rule. So trickery dickory, if the E is big and normal, and then you have a number in the air, it just goes to 0. Oh gosh, yep. Okay, so this E to the squared just goes to a 0. Okay, so let's just clean it up. The derivative of the letter y is y prime. And then I'm just gonna smash all this together. 13 to the x, and then right next to it, ln 13. Whoa, awkward. Okay, let's go to k. It says 19 to the x. Well, we know what that is. It just goes to 19. Okay, So 19 plus sign, ln, with something more than just an x inside. Oh gosh, okay. So we're gonna look at the ln rules, but when there's more than just an x inside, over here, it's 1 over the stuff from the inside, 1 over the stuff from the inside, 19x, times the derivative of the stuff inside, times the derivative of this 19x inside. Well, the derivative of 19x is just 19. Yeah. Okay, so let's clean it up. We have a 19, then we have a plus sign, and then we have two things multiplied. So when we have fractions and they're multiplying, we can put a pretend 1 under whatever doesn't have it, and then we can multiply left to right. But we're not multiplying anything before this plus sign, okay? Because that would be plussing, and we're just trying to multiply. So we're only gonna multiply what's after this plus sign. So 1 times 19 is 19. On the bottom, 19x times 1 is just 19x. And then, odd, look at that, the 19s cancel. But only after the plus sign, okay? They do not cancel diagonally if there's a plus sign. They cancel diagonally if there was a multiply, like on... I thought we did that. Darn it, I thought I already talked about this. Did I? No, I guess not. Okay, so anyway, fractions can only cancel diagonally if there's a multiply sign in between. So if this little plus sign was a multiply, then I could probably cross out this 19 on the bottom with this other 19 on top. But because this is a plus sign, that means these are two different things. So we cannot cancel diagonally, only if there was a multiply. So anyway, these 19s cancel up and down, and I have to put something on top. I can't put a 0. What is 19 divided by 19? Oh, it's 1. Okay, so I'm gonna put a 1 on top. So I get 19 plus sign, 1 over x. Hey, that's the derivative, or f prime of x. Yeah, let's keep going. It's almost word problem time. Okay, these next suckers have to do with the equation of the tangent line. It says find the equation of the tangent line, blah, blah, blah. Okay, well, we know how to do this, sort of. We have to take the derivative. So let's take the derivative because we have to find the slope. Okay, so my first thing I'm gonna do is I'm gonna take the derivative. And the derivative is the 3 goes away, the 2 brings down, okay, and then let's see what happens to the ln x. ln. Oh, here it is. Oh, we have a little trick for this. When you just have a number, ln x, it turns into number over x. Yeah, we already figured that trick out from doing a previous example. So this is just gonna be 2 over x. Hey, baby. That's the derivative. And what is a derivative in terms of a tangent line? It's the slope. What letter is a slope? It's the letter M. Okay. So the thing is, our slopes are usually fractions, but as in fractions with only numbers. This has a letter X in it. So now what we're gonna do is they said x equals 1. We're gonna plug in this number 1. So our second step is we're gonna plug in x equals 1 into the derivative. And that will give me a slope that is just a plain old number, not a number with an x on the bottom. Okay, so if I plug it into the derivative, it's gonna be 2 over, instead of x, I'm plugging in a 1. And what's 2 divided by 1? Hey, that's just 2. So my m is 2, or my slope. So my derivative gave me the equation for my slope. Then I had to plug in whatever number they gave us for x to get the actual slope that's either a whole number or a fraction. Okay, now, eventually we're going to have to do this equation, y equals mx plus b. And it looks like I have a m, woohoo, 2. Looks like I have an x, woohoo, 1. I don't got my b and I don't got my y, but I can find my y. So my next step before I can do this y equals mx plus b is to find my y. And to find my y, I'm going to plug in that 1 into the original equation. Original, not the derivative. Okay, so I'm going to say f of 1, because they gave us x equals 1, equals 3 plus 2l in 1. And then I'm going to put that in my calculator and pray that it comes out like a regular old number. 3 plus 2. Ln is right here by the number 4. It looks like IN, but that's a lowercase l. Oh my gosh, it just gave me 3. That's so exciting. Okay, so this says that f of 1 is 3. That means x is 1 and y is 3. We just found our y value. Okay, next, let's plug it into y equals mx plus b. Okay, so we're going to have the letter y, which is 3, equals the letter m, which was step 2, and it was a 2, times the letter x, which was what they gave us, 1, plus b. And then now let's get our b by itself. So we get 3 equals 2 plus b, subtract the 2, and we get b equals 1. Okay, now we're going to throw it all back into this original y equals mx plus b, but we're only going to put a number where the m and the b are. So we're going to keep the letter y, keep the equals, the m is whatever number it was, 2. The x is still the letter x, plus sign, and then our b is whatever we just figured out, 1. Hey, that's the equation of the tangent line. And your homework should take that. If it doesn't take that, it's because you did something wrong up here. Maybe you messed up a sign or something. Usually the homework wants you to type in something like this, you know? But I've gone through your homework and I've typed my version and it does work. You have to make sure your numbers are correct. Okay, let's keep going. Let's do another one. We're still finding the derivative. So my first step is to find the derivative. So let's see here. I know 6 to the x just goes to 6. That's exciting. But then let's go see what 3e to the x was. Well, we kind of made our own little trick for that earlier. We said number e to the x is just the exact same thing. Number e to the x. Okay, let's go. So the derivative of 3e to the x is still 3e to the x. The derivative of 6x is just a 6. Okay, well, this represents my slope. Now I'm on to my second step of plugging in x equals 0. So instead of this little x in the air, I'm going to put a 0 because this derivative represents the slope at x equals 0. So to find the actual number of the slope, like 1 over 2 or something, I got to plug in this 0 so that that letter x will go away. So 3e to the 0 and then plus 6. Okay, let's type this in our calculator and hopefully it comes out with something good looking. So I'm going to type 3. Okay. E to the x, there's a couple of different ways you could do it. You could press second in this divide because there's a little blue E above it. Or you could press this sucker, LN, but you have to press second LN first. You cannot do alpha and then this sign because that's a capital E. We need a lowercase e. So these are the only 2 buttons we could press to get the lowercase e. But this one by the 4, it already has an exponent in it. So that's what I'm going to do. So I typed 3. Then I'm going to press second, ln. Oh, and hey, there you go. Then I'm going to put a 0, and then you might have to close your parentheses. I think my calculator is in the old format. I'll show you the new format in a minute. So 3e to the 0 and then plus 6. Hey, it gives me 9. Exciting. Okay, if you have a newer calculator, it will look like 3 and same second ln, only that 0 will be in the air. And then make sure you arrow out of the air to press plus 6. Oh, it's still 9. Okay. So this gives me 9, and that's the letter M. Okay, now my third step is look to the future and remember what your fourth step is. Your fourth step is y equals mx plus b. Well, I know my m, it's 9. I know my x, it's 0, but I don't know the y and I don't know the b. Well, I have to figure out the y first. So to figure out the y, we're going to plug this x equals 0 into the OG equation, the original, the f of x. So I'm going to plug this 0 into the original f of x. So f of 0 equals 3e to the 0 plus 6 times 0. And let's see what that gives me. 3 and then second ln 0, arrow out, plus 6 times 0. Oh, I knew that. And it just gives me 3. So this says f of 0 equals 3. That means x is 0 and y is 3. Okay, now let's go to this y equals mx plus b equation. I know that my y is 3. I just found it. I know that my m is 9. It's from step 2. I know that my x is 0. It's from what they gave you. And I don't know my b. Plus b plus b. Okay, now let's do this. This is 3 equals 9 times 0 is just 0. I don't even have to write that. So I'm just going to write b. Okay, the last thing is to go back to this y equals mx plus b and put a number in the m and the b, but everything else stays the same. So y equals the m, which was 9, x plus the b, which was 3. Hey, baby, done with that sucker. All right, let's look at this word problem. Okay. It says S of t equals blah, 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 equation. What is the rate of depreciation after 1 year, 10 year? And S of t is the salvage value of a boat. And t is the amount of years passed. So if you've ever purchased a boat or a car, they say as soon as you drive it out of the lot, it depreciates and it's not worth as much money as in if you buy a car for $50,000 today, when you go back in 6 months, it's not worth $50,000. It's worth less. So this describes how much money the boat is worth after a certain amount of years, and the amount that it's worth will go down because it depreciates in value. Okay, so it says, what is the rate of depreciation? Rate means slope. Slope means derivative. Oh, okay, so we're just finding the derivative. Let's go. Okay, first let me write this equation again, because I want to be able to scratch things out. And I'm not going to write that comma, because if I try and put that comma in my calculator, it's going to screw me up. Okay, so this t is in the air. Well, let's go back to our tricks for how to find the derivative of something that has a number that's big and normal and then a letter in the air. So a number that's big and normal, oh, it's this one, exponential rule. When you see a number that's big and normal and then a letter in the air. Usually we have the letter X, but here, since we're talking about time, we have a letter T. Okay, so it says to take the derivative. First, we're going to bring down this 300 because as we've seen in all the other examples, this number on front just flows down with you. Okay, then we're going to multiply it by the same number to the x. Okay, by the same number to the x, or the letter T. Then you write ln of that number. ln of that number, 0.8. Okay, well, that's my derivative. So exciting. This is equal to my slope. And obviously, I don't know how to rise over run this sucker. This is dirty. Okay, so to get an actual number for the rate of depreciation or the slope, how the boat decreases in value, we have to plug in 1 year. As in, we're going to plug in the number 1 into the letter T. So we're going to say S prime of 1 is equal to 300,000, 0.8 to the Juan, parentheses ln 0.8. And this is probably not going to be a pretty number, but that's okay. It's okay. I think we're going to round it. Well, let's see what we get first. Okay, so 300,000, 300, parentheses, 0.8, parentheses. Then we put that 1 in the air. 1. Then we come back down. And I know that was kind of useless to put the 1 in the air, but I wanted to practice because in a second I'm going to put a 10, and that is going to matter. Okay, so we're going to have ln 0.8. Okay, parentheses. Hey, the ln button is just this button beside the 4. Just press it once. ln 0.8. 0.8. Close your parentheses. Oh, whoa. Okay, so this gives us negative 53. Let me write this down. Negative 53, 55, 4.45232. Okay. So, this describes how much money you lose on that boat after 1 year. Let's maybe round it to make it look like money. Money only has 2 decimal spots. So this is going to be, it's money. So negative 53554.4. We just want 1 more decimal. So since this 2 is 4 or less, we're going to let that 5 rest. So, oh, and it's negative. So this means that we lose, what is this? 53,554.45 cents after 1 year. So if I buy a $300,000 boat after 1 year, it's worth $53,554.45 less, as in it's only worth like 253 or 250-ish thousand. So after 1 year, you lose this many dollars. Darn. Okay, now let's find after 10 years. Well, we're going to plug in a 10 into the air instead of a 1 in the air. So let's do it. We're going to have S prime of 10 equals $300,000. 0.8 to the 10, and then ln 0.8. Okay, and now I'm going to type it in. So I put a 10 up in the air, and oh my gosh, negative 7,187.95. Sorry, let me write this down. Negative 70. 87.956. Yeah. I think I wrote it down right. Yeah, I did. Okay, so this is in money, so let's make it look like money. So negative, and then 7187, that's $7,187.96. So that means in the first year, we lose $53,000. That's a ton of money. But by the 10th year, in that 10th year, we only lose about $7,000. So this shows that depreciation, as soon as you drive off the lot with that boat, after the first year, that's when you lose the most amount of money on that boat. And then every year after that, you lose a little less and a little less.